Hello, greetings of the day. This is Irfan here. Today I will talk about something that looks mathematical but is actually very logical. And the topic is normality and dilution law. Think of this topic as learning how chemists control strength the same way you control sugar in your tea. At the end of this video, you will come to know how this dilution law works and what is the expression for it without boring you with derivations, with long mathematical derivations. Am I right? But before going into normality and dilution law, let's understand few basic terms that will be handy in understanding the concept fully. For example, the first term is strength. Strength. What this strength means. At this stage, since I had to finish it up within 12 minutes, at this stage, let me make you understand the strength in a one line. If you are given a solution, for example, you are putting salt, 1 spoon of salt in 1 glass of water, or 1 spoon of salt in another bucket of water. If you are asked, what is the nature of substance? It is same. Solute is same, that's salt. But volume is smaller in glass of water and volume is larger in bucket of water. So the strength changes. Substance same, solute same, salt is same, but the strengths are different. Now what this strength actually means? Strength means how powerful a solution is. How effective a solution is, right? How powerful a solution is. I can write it, how powerful a solution is. Or how effective a solution is. How effective a solution is. Why I'm explaining to you this strength? Because I had to derive 2 or 3 things from it, which are very important in understanding the normality. This strength, it depends upon nature of solute. Nature of solute, this is the first thing it depends upon, right? Second thing, it depends upon n factor. N factor, and third thing, it depends upon concentration. And this is a term that we have to make use of in normality, right? Nature of solute, everybody knows. N factor. What is n factor? For example, you have an acid. Now, the basic property or the basic definition of acids is that acids furnish H positive ions when they are dissolved in water. So HCl is there, hydrochloric acid. It gives 1 H positive. H2SO4 is there, sulfuric acid. It gives 2 H positives, right? Now, how many H positives an acid furnishes? That's N factor for an acid. You have base, for example, sodium hydroxide is there. It gives you 1 OH negative because bases are defined on the basis of the fact that substance furnishing OH negative ions. Now NaOH furnishes 1 OH negative ion. CaOH whole twice, it furnishes 2 OH negative ions, right? So the N factor for base NaOH is 1 and N factor for base CaOH whole twice is 2. Or you have some reducing agent. You know, reducing agents are those substances which lose or gain electrons. Simply speaking, transference of electrons. Now, how many electrons a reducing agent is releasing or accepting, right? That's N factor. And strength depends upon N factor. Am I right? And simple terms, this N factor is actually the unit of chemical work. Unit of chemical work. For example, job of an acid is, the job of an acid or the work done by an acid is furnishing H positives. How many? N factor. Base furnishes OH negative. How many OH negative? N factor. Reducing agent loses or gains electrons. Right? Redox reagents loses or gains electrons. How many electrons? N factor. And then concentration, the third term on which strength depends. What is this concentration? Simple terms, how much active substance a solution contains. How much active substance a solution contains. Or more simply, I can make it, I can say the amount of substance in a given volume of solution. Amount of substance in a given volume of solution, that is concentration. Fine. Now, this concentration, that is amount of a substance in a given volume, that is your concentration. And how to express this concentration? You have molarity, you have molality, and you have today's hero, that is normality. Got it? Normality. Now what is this normality? Let's go into it. Normality. Normality is number of gram equivalents in 1 liter of solution. I will write it. Number of gram equivalents in 1 liter of solution. Am I right? Number of gram equivalents in 1 liter of solution. Now the key word is equivalent. What's equivalent? Fine. What's equivalent? Now, I will give you a situation, or I will give you an analogy. There is a weight box and an adult can lift it. Okay? One adult, he can lift it. Now 2 children came. They also want to lift it. They lifted it. Weight box same, individuals different, right? 2 children, 1 adult, different. The work done, the same amount of work done, which is done by 1 adult, is also done by the 2 children. Same work is done, different people. So equivalent is, in the similar fashion, we can explain this equivalent. Different amounts of substance that can do the same chemical job, that can do the same chemical work. And what is the chemical work or chemical job of a substance? Job of an acid is releasing protons. Job of a base is giving OH negatives. Job of a redox reagent is transference of electrons. Am I right? That's equivalent, basic definition at this stage. Okay. So, number of gram equivalents in 1 liter of solution. HCl is there. For example, HCl. It gives us 1 mole of HCl. 1 mole of HCl gives us H positive. The same job is being done by 1/2 mole of H2SO4. It also gives you H positive. Half of. Because 1 mole of H2SO4 gives you 2 protons. Half of mole of H2SO4 will give you 1 proton. The same work done by HCl, H2SO4, equivalent. Okay? Equivalent. Now, so normality is number of gram equivalents in 1 liter of solution. Now let's see how we can prepare one normal solution. Okay? Let's take the example of king of chemicals, and that's H2SO4, H2SO4, H2SO4. Okay. So what is the molecular mass, molar mass of this substance? 98. You know 98 simply. H2 means 2 units, sulfur means 32, oxygen means 64 because one oxygen has 16 units of mass and 4 oxygens will have 64 units. 64 plus 32 plus 2, that's 98. Okay, so normality, it will be 98 molar mass divided by n factor. What's n? N is number of protons released, furnished by H2SO4, that's 2. So it will come out to be 49. That's equivalent mass. Equivalent, you can say at this stage, equivalents. So 49. Now if I take 49 grams of H2SO4, okay, and I dissolve them in 1 liter of solution, 1 liter of solvent, it will become then solution. Okay, it will be one normal solution, one normal H2SO4 solution. Am I right? So this is how we prepare one normal solution. Now let me give you a situation. Now let's create a situation. A situation is simple. I have got very strong tea. Okay, I have got very strong tea, and strong in terms of sugar content is large in it. Now I want to serve this tea to someone who doesn't like sugar. What I will do? I'll simply put a glass of or a cup of hot water into it, right? So I had strong tea. Strong tea. Fine. What I am doing? I am adding to it glass or cup of hot water. Hot water. Am I right? Now, what happened here? Has the amount of solute changed? Yes? No. It's constant. It hasn't changed. Okay. Has the strength changed? Has the strength changed? Changed. Yes, of course, strength has changed. Now what happened to strength? Strength has decreased. Okay. Okay. Now, has the volume changed? Has the volume changed? Yes, sir, it has changed. What happened to volume? It has increased. Okay, volume has increased. And this is dilution. This is where the concept of dilution comes. This is dilution. So you increase the volume of a solution, it will lead to dilution. Now before dilution, you had N1V1, and after dilution you have N2V2. Okay, N1 initial normality, V1 initial volume, N2 final normality, V2 final volume. So initial equivalents you can say, final equivalents you can say. Okay, but the amount of solute has not changed. That has remained constant. That has remained constant. Therefore N1V1 is equal to N2V2. Simple. No mathematical derivation. Only conversation process, conversation concept. Okay. So let's do a numerical on it. A simple numerical will do. Question. 2 normal, or you can say 20 ml of 2 normal solution is diluted to 100 ml. 100 ml. What is the final normality? What is the final normality? Hold on. It was simple. Given is initial volume, that's V1. What is that? 20 ml. Initial normality, N1, that is 2 normal, right? Final volume, V2, that is 100. What do you have to calculate? N2. So what you will apply? N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. Okay, N1 V1, it is 2 into 20. N1 is 2, V1 is 20, 20 ho gaya 40. 40 is equal to, N2 is to be calculated. N2 is to be calculated. N2 into volume is 100. Volume is 100. So it will come out to be equal to, therefore, N2 will be equal to 40 divided by 100. 40 divided by 100, that's 0.4. 0.4. Simple. This is how we apply dilution law to calculate the exam oriented, these numericals and everything else. Okay, so remember this analogy, that how we understand, how we reach at the concept of dilution. Take the strong tea, dilute it, add some add 1 cup of hot water to it. So that's all. So hope you have liked it, and let's move together and let me be part of your academic experience.